Chapter number 2, measure of locations and spread. This is a data set about 14 apples, the weight of a 14 apple. We know that instead of this 14 data, if we have one single value which represent all the data, then it is easy us to handle and to come to a conclusion like mean, median, mode. So they are those are single values which represent the data set. You can come to a conclusion by looking at mean of the data set or median of the data set or mode of the data set. And when we have these combinations, we can select the best option. It can be mean or it can be median or it can be mode according to the data. And measure of locations is uh, is a single value which describes the position in the data set. Yes, this is a single value which describes the position. Position in the sense at the end, these all numbers are on the number line. So then the number is a position of a number line. Hence, the mean, mode, and median, they are all positioned in a number line. That value represent a position in the number line. A measure of a location, measures of a location is a single value which describes, this is the book meaning, definition, which describe the position in the data set. If the single value describes the center of the data, then it is called measure of central tendency, which we'll discuss. So mean, median, and mode are single values which describe the data set. Now we'll discuss about mean, then the median, and then mode. Already you know in GCSE, but just for a few minute discussion. So this is a simple data set. Let's find the mean of this one. Mean is 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 divided by 7, that is 21 divided by 7, that is 3. Now this represents all piece of data, hence it's give a true measure. Yeah, because if you take this one out, 2 out, it will affect this number. If you take 2 out, this 3 will, the 3 will be changed. But as you mean, mode or median, what is the median of this one now? So median is this number. Median is 3. Now, if I take from this 2 out and 4 out, two numbers, and this value will be, mean value will be changed. But if I delete those two numbers, do you think that median will be changed? No, still median is 3. That's not a good sign, because that this median doesn't represent that number. The other one, mode. This is 2 and 4. What is the mode in this data set? The mode is 3. So I will delete those two 1 or 2 numbers. What is the mode now? Still 3. So that 2 and 4 doesn't represent by this mode. So that's why it's called the mean. It's a true measure. It will affect, if you touch to a number, it will affect to the mean. However, it is affected by extreme values. What is the meaning of that? The meaning of that is, so assume that this data set 2, 2, 3, 3, and 4. Let's say this is a weight of a small insect, and accidentally there are abnormal one of them. We know the median is 3 here. So mean is 3. Extreme values. First of all, you should know what is extreme values. Extreme values in the sense abnormal values. Assume that if I write a set of apple is 78 grams, 80 grams, 90 grams, and another one you accidentally saw that 1.5 kg or 1500 grams, like a coconut. So 1500 grams or more. So this is the extreme value. Sometimes you in the upper garden you may find this really okay. Let's say I'll bring to a much reasonable value, 400 grams. In this apple yard you can find 400 grams apple. Why? Because accidentally in this apple garden, for that apple the fertilizer packet was accidentally uh, fall onto it, or by accident worker put more urea to it, or the more fertilizers, and it's helped to become a big apple. Now only this problem is on this particular apple tree, and the others apples are normal. And because of this apple, and when you get the mean, it will give a mean more than 78, 89, 99. So what is the mean of? So mean of this apple is 164, which is not realistic. Because of one apple, just because of one apple, it shows that the mean is 164. And if I tell, without telling this information, telling this extreme value to Apple buyer that okay, I have 164 grams average mean apples, the buyer is really happy. Why? Because he assumed that all the apple, most of the apple in this weight. Unfortunately, that's not the reality. In reality, only just one apple is 400 grams. And so either that abnormal one can be it is more bigger, or sometimes it is too small. How about that is I will tell that 12 grams one. Then what will happen? So now mean is 67. It is not that bad, it's not that confusing, but when you compare 78, 80, 99 range, 60 is much lower. Now Apple buyer think that oh, this is a um, bad farmyard because the weight is very less, which is not just a one apple 12. All other three apples are in the right scale. So because of that, so that's mean. Uh, so it is affected by extreme values. So if we have extreme values, then we have to look at one more, median or mode. The other measures of locations to get a decision on this farmyard of apple. As you know, we have this is weight of few apples. Now we have a formula. First of all, I like to discuss this formula. X bar uh, x bar equal summation x and over n. What is this x bar actually? X bar is a sample mean. In this statistics, why we are taking a sample? To predict about the mean about the population. Now, what is population? Population here is your objective target people or target data. For example, I want to measure the height of the children in year 9 in all England. So I want to measure height year 9 all UK. So now this is my target population, target crowd. So target data. Oh, it is not possible. So if I select or if I take all the students, if I measure all the student, the height of the all the student, and if I find the mean, that mean is called mu. And then you will learn something about the standard deviation, that is sigma. But we can't find for whole population. Because of that, we are taking a sample out of it. We pick up some people around UK and we take one sample. So now we are looking sample mean. That sample mean x bar and sample standard. Sorry. So what is the task of this x bar? The task of the x bar or the sample mean is to give an idea about the mu population mean. So that is usually we refer as x bar. And when I look at this one, we need to understand this what is really about this summation. This summation mean the idea behind it. This is x bar equal summation I equal 1 to n x I over n. What is the meaning of that? Now for this data 1, 2, 3, 4, 5. Then n value is 5. Then we write x bar is summation I equal 1 to 5 xi and divide by 5. So now this part I equal 1 to 5 xi. What is the task of this one? I equal summation I equal 1 to 5 xi. The command is this. From 1 to 5, find xi and add. Or when I equal 1, x1. Then add to that, go back again. Then what is the after 1? 2. Then I equal to x2 plus. Then go back again. x3. Then go back again. x4. And then when it's come to x5, we stop it. Then what is x1 plus x2 plus x3 plus x4 plus x5? What is x1? 77. And x2, 80. And x3, 81. x4, 81. So 87. So instead of writing this command, so this is the simple way of writing. Go one by one and add. When x equal 1, take 1. Then add to that one when I equal 2. Then add to that when I equal 3. And add to I equal 4. And add to that I equal 5 when it's count to 5 stop. So this is the idea behind it. The summation sign. But we simply write summation x over n. Now there is another equation. X bar equal summation x f over summation f. So the idea is x bar is I equal 1 to n xi fi over summation fi. The same thing. X1, this is x times fi. Now assume that when these data in a table like this, so this is going to be the measurement x, and this is going to be the frequency, number of times. We can see 77, only one, and then 80, only one. So and 81, two times, and 87, only one time. Now when you have a data in a table like this, then we have to use this formula, or with your understanding. Um, Actually, I'll come like this: 77 plus 80 plus 81 plus 81 plus 87 divided by 5. So it is easy. So this is mean when we find in. So instead of writing 77, so 77 plus 80 plus 81, assume that writing 2 times 81 times 2, because if we have this method, so I will put 81 and 81 and 87. Now 1 2 3 4, there are 4 81s. So then 81 plus 81 plus 81 plus 87 divided by 7. So instead of writing 81 plus 81 plus 81 plus 81 plus, we can simply write 81 times 4. And then 87. So this is the idea behind it basically. So instead of writing one by one, if we have a table, so we are writing mean 77 times 1 plus 80 times 1 plus 81 times 4 plus 87 times 1. So some x times f, 77 times 1, x times f, x times f, x times f, and divide by summation f. This is the summation f7. So this is this formula. This formula will tell if I write to this one now, x bar equal summation I equal 1 to 5 xi fi times divide, yes, fi. So only the summation is imposed here. So this is going to be I equal 1, that is x1 and f1. What is x1 f1? 77 times 1. Then add summation. Then come to again I equal 2. So 1 to 5. So 1, 2, 3, 4, 5. Then I equal to add x2 f2 multiplication. Then 80 times 1. Then x3 f3. Uh, 80 times 2 and x4 f4. 1, 2, 3. Sorry, 81 times 4, this one. 1, 2, 3 and 4. 87 times so this has to be 1, 2, 4. 87 times 1 and divide by summation f I. If I equal 1, I equal 2, 3 and 4. So that is I equal 1 is 1, 2 and this is 3 and this is 4. So basically 1 plus 1 plus 4 plus 1. So this is the idea basically. Now I rewrite this data set again. Now when you have lots of data, not like this few, but lots of data, 81, 81.2 likewise, so it's difficult um, to go one by one. Then in that case we are limiting, we are bringing to a limit or a interval. For example, I'm going to introduce a interval for this data set 70 to 75, 76 to 80, 81 to okay, this is 71, 76, so 81 to 85, then 86 to 90. Instead of writing one by one, when we gather the data, now assume that I'm counting now. 71 goes where, in which group? uh, 71 to 75, right? 77 77 goes here 1 and 80 goes okay here sorry, here 1 and 80 goes here again, 81 goes here, 81 goes here, 81 goes here, 81 goes here, 87 goes here. Actually we don't need this one. Now 76 to 82 and 80 to 85, 1, 2, 3, 4 and this one 1. So this is the F. This is we call class interval. So this is the interval. There are classes of this is class interval. Assume somebody bring those data to you. Now you don't know what was the raw data. Now this is the process data you have. Half of process data. You don't know what are the original data. Now you know 2. The frequency is 2. Now it is 76 to or 77 to or 82 or. So what is the number? This 2 represent which number? 76 or 77 or 78, 79 or 80. Now this is the issue. To avoid this issue, what do? We are taking the middle number of this interval 76 and 80. we find the middle number, we add those two together and divide by 2. 76 plus 80 divided by 2. So now this is 78. And 81 plus 85 divided by 2. This is 78. So this is 78, 83 this one, and this is 88. Now we don't need this one now. Now we have the, we can find the mean. So what is the mean now? X bar equals summation xf. So this is x and this is f. We don't need class interval now. Divide by summation f. So 78 how many? 2's. And 83 4's. And 88 1's divided by summation f. So this is 7. I rewrote these class intervals, and I'm going to discuss a bit about this class interval. I like to draw a number line, and then this is 76 to 80, then 81 to 81 to 85, then 86 to 90, right? Now 76 to 80. Yeah, so it is 76 to 80 here. Now there is a gap in between 80 and 81. This is the gap. Then there is again gap between 85 and 86. So this is not continuous in other way. If you, sometime we may need, if we draw a histogram, we don't need this kind of class intervals. We need a continuous class interval. So now 80 to 81 gap, 85 to 86 gap. So how are we going to, what kind of technique we are going to apply to make it continuous? So the technique is we have find this gap. So 81 and 80 here. So what is the gap? Then 81 minus 80, 1 unit gap there. Then this, whatever the gap, divide by 2. So then half a gap. It means 0.5. Then what do we know? We are minusing. Okay. When I consider this one, so this is 76. This is 80. I rewrite here. This is 81. The magnified version of it. This is 85. Now, a gap is 1 and half of the gap is 0.5. I will add to 0.5 here. I'll add to 0.5 here. And I minus 0.5 here. So when I add 0.5 here, what is the answer? 80.5. And when I minus 0.5 from 81, what is the answer? 80.5. Then instead of these two columns, I am bringing one column. That column is 80.5. So likewise, now I don't have 80 and 81. Now I have one column that is 80.5. Instead of 85 and 86, can you guess what is happening now? It is going to be different is 1. Add 0.5 to here. Then it is going to be 85.5. 85.5. Now this one. What is this one? We want to bring a little bit further left. This is going to be 76, 75.5. We have to reduce that one because this one is, and here not 90 anymore. It is going to be, this is 75.5 and this is going to be 90.5. It means now the new interval, new good interval is continuous interval is, I avoid this gap. I cut this gap by adding and minusing the boundaries. So for the left boundary, take zero point 0.5 out, that is going to be 75.5 to this one, add zero point 0.5. Then 81 become 8.5 and 85 become 85.5. Basically we add zero point 0.5 to here. So this is 90.5. We minus zero point 0.5 from here. So 86 minus 0.5, 85.5. So now 75.80.5. So 85.5 to 85.5. Now when we write this kind of interval, so in this class interval there is a gap in between because there is 80 to 81 there is a gap, and 85 to 86 there is a gap, 90 to 91 a gap, 75 to 76 a gap. So now we get rid of this gap, but now there is a one issue of this one. Then if you get 80.5, are you going to consider this one or this one? Now it is our convention that the way we decide, either you can put it here or here. So whatever it is, you have to apply the same theory to others. Assume that if you want to get 80.5 here, then you have to write differently. 70.5 greater x greater than or equal to, now we have to write with these symbols. So what is the meaning? If you come 80.5, put it here. Now it is here, then 80.5 greater x. The same theory you have to apply now 85. If 85 point come, it should be here. Then 85.5 to x 90.5. So this discontinuous continuous. Discontinuous interval make into a continuous interval. Then we have a issue where we are going to put 80.5. What is the place we are going to put 85.5? Then we come to a decision that okay, we'll put into this one. Then we have to follow the same thing to others. If you decide to bring into this one, then it's like this. Then equal. So now we have the 80 point. Don't put there, put it here. So it's up to you, the place you can decide. And let's discuss about median. Median, as you know, that is value of midpoint of ordered data. It is usually used when there are extreme values. So values of midpoint of ordered data. Ordered data means either we want to write in ascending or descending order. So this is, I wrote some data. So this is not in ascending or descending order. So we'll put into a ascending order. So this is going to be 77. Then the next one is 79. Then 80, 81, 85. Now this is the ordered data. So this is non-ordered. This is ordered data and ascending order. So when you order it like this, we can easily find the midterm. So how this is first term, second term, third term, fourth term, fifth term. So what is the midterm? If we start uh, crossing out, this is one way of doing it. So the T3, so this is the midterm. So T3 equal 80. So value of midpoint, or we can write midterm. So midterm is 80. The second method is finding the midpoint is if assume n is the number of data, then n divided by 2. If n divided by 2 is a whole number, and the answer can be non-whole number. If it is a whole number, what do you do? You have to take this term and the term above, take take the value of this term and the value of the term above, value of the term above, and average it. If it is whole number, non-whole number, round up, round up, not down. Let's discuss one example. So here, what is the n value? 1, 2, 3, 4, 5. So n is 5. So n divided by 2 is 2.5. Then round up. So round up value is 3. So then you have to pick up the value of the third term. So round up and pick up the value of this term. So now round up. So n divide non-whole number, round up, and then this is the T3 term. Pick up the value of this term. So the term is 3. What is the value of this term? Is 80. What will happen? There are even numbers. I'll put this is 60, 79. I'll put 70, 77. This is, I put 75. Another one. Then what is the new medium? The new medium is now n equal 6. N divided by 2 is 3. Right? Take the value of this term. So what is this term? T3. So what is the value? 1, T1, T2, T3, term 4, term 5, term 6. So that is 79. Then and the value of the term above. So what is the above term? T4. That value is 80. Then what I need to do? Average it. It means T3 plus T4 divided by 2. 79 plus 80 divided by 2. which is going to be 79.5. So that is the medium, new medium. Uh, Total value of the term. So let's say this is term whole number. You will get m. Then pick up Tm, and then the one above Tm plus 1 and average it. It means Tm plus 1 divided by 2. Tm, so n equals 6, n divided by 2, 3, then term 3, and the other term is 10, 4, and average is T3 plus T4 divided by 2. So what is T3? 79, and T4 80 divided by 2, 79.5. Now this is for discrete data. This every calculation is for discrete data. Now we have to discuss about continuous data. We'll do a discussion on that now. So discrete data, what is discrete data? As we discussed previous section, discrete data, for example, assume that this is a number of petals in a flower. So then one petal, two petal, three petal, there is no half a petal or 4.5 petal. It is all are whole numbers, positive integers. But if it is a continuous data, for example, that variable is this variable is number of petals. But assume the variable is height of a tree or the weight of an apple. So how do you measure weight of an apple? Using which scale? Continuous scale. Basically, uh, as we know, finally, whatever it is, we are using number line to measure, right? So if we use the integer values only, then that is going to be discrete data. But if you use whole number line, right, real numbers, 8.5, 82.5, for example, if I take the weight of apple, assume minimum 70 and maximum 150. So 7 to 150, it can be any point. The weight can be 7.1 gram, 7.111 grams, right? 7 point. So we are using continuous scale to measure this data for the weight of apple. But to count number of petals, we are using discrete, the integer values, positive integers of the number line. So then it is discrete data. This median also called second quartile. Second quartile. Then what is first quartile? We'll learn soon. We are going to learn soon. First quartile and third quartile. Medium means second quartile. So how do you find the second quartile? N divided by 2, whole number, non-whole number. Non-whole number, round up. Whole number, take that term and the one above and average. Simple. And the continuous one, we are working with the interpolation. So when we learn the interpolation, we'll go with that if we have a continuous data. Midpoint usually we refer when the data is continuous. Midterm usually we refer when data is discrete. It doesn't matter if you use midpoint for both, that's fine. Now I bring the normal data set. So this is I'll bring into the order data set now. Here it is usually used when there are extreme values. So this median is usually worth when there are extreme values. For example, when you take this one, for this data set, mean is 80.4 and median is 80. Now I will delete this one and I will write the extreme data around 200. Now new mean is 103.4, but median is still the same, 80. See that because of this value, the mean is unacceptable value, become unacceptable value. But median is still the same. So then median is useful uh, when there are extreme values in the data set. And if we can't move this extreme value, then we want to consider the median. Next one is mod, the most common value in the data set. If it is not very important if each value occurs once. The most common value in the data set, for example, 77, 78, 80, 80, and 81. So when you look at this data set, 77 is 1, 78 is 1, 80 is 2, 81 is 1. So the 8 is the value 80 occurs two times. So then the most common value is 80. The mode is 80. Sometimes it can be bimodal. There may be one or more. So this is one mode. There may be two modes. So 81, 82, and 82, and 83. Now 77 1, 78 1, 82, 81 1, then 82 twos and 83 ones. Now this is bimodal. They they have this data set have two mode. So one is 80 and the other one is 82. This is called bimodal or sometimes multimodal. If there are more, usually one or two, but it can be more. And so this is for discrete data set. Discrete data. Sometime in a class interval, it can be a class interval. Um, when you look at this data set, so this is class intervals. So from this class intervals, which interval is occurred most times? So 76 to 80. So the model class is this one in that case. If it is an interval, we don't know what are the row datas.